Hello, my name is Wiebe. You can call me Wiebe. That's usually easier for English people. And I've been sitting on this idea for quite a while. And when I ask people, or when I tell people I'm working on a tool to search VIs like a graph, I get a lot of, I never need to search for LabVIEW in LabVIEW. Which is a bit weird to me, and I can only imagine that you just started LabVIEW, or you stopped using LabVIEW, or that you know every code that you're working with by heart, or, and this is probably the most likely, that you've been using LabVIEW for so long that you've given up. What's the click? Doesn't click. Oh, I have to put in the USB thingy, I guess. There it is. And now I have to find the clicky again. Which one? No, okay. It doesn't even click in PowerPoint. Well, at least there's entertainment. So glad I put those in.
Is that already part of searching and finding?
Yeah. It's a treasure hunt. You have to count them and why? So I'm not just talking about searching these kinds of VIs. Those are horrible, and yeah, you would want to search in those. But even if you make reasonable code, no, that's backwards. Yeah. So what if you have shared what they call global functional globals, right? And you have a whole bunch of them. And you can find all instances of the type def, but you get all of them. And you can search for init, but a lot of stuff might be called init, right? So especially if you go, usually if you go functional global, you have a lot of functional globals, and all of them might have an init, and you'll find all inits. But even if you have an enum coming out of VI, you can find all instances of the enum, but you won't find the VIs using the enum like this. And other stuff like queues, you don't want to search a queue, you want to find a value wired to the queue so that you know where stuff is enqueued. And if you go queues, you usually have a lot of enqueues, so finding all the enqueues won't help. Searching objects, but then only get those with certain properties like disabled controls, or maybe for loops with an unwired iterator. Or those annoying terminals that are set to icon. If you have any questions during the presentation, so I'm open to answering them. Yeah, I'm not sure how it will work with the mic, but maybe you just have to shout. So a few reservations about this presentation. It is an idea, just an idea. It's not a complete project or a complete tool. It's primitive and crude, rough around the edges, a work in progress. And it could be trash, I don't know. I never pitched it before. But I am myself starting to use it. What I'll be showing is just the tip of the iceberg, so I hope you can all interpolate or extrapolate. If I show really advanced stuff, then nobody will get it. But there will be a few demos, so I hope they will shed some light on stuff. There's quite a bit of theory before you be able to appreciate those demos. So this idea started with the notion that the VI is a graph, a VI is a graph, and that there are graph databases. and I assumed that people could query those graph databases. So can you use the queries used to query graph databases to query VIs? Yeah, spoiler, I think you can. So when I started this, I didn't know anything about query graph databases or query languages. So I had to study that quite a bit. I found the most common, well, you can just use ChatGPT and ask for the most common graph query languages. Gremlin is resonated with me. Other languages are like Cypher and GQL. But I liked Gremlin. It resonated with me, and immediately, like VI Gremlin sounded good, kind of like a cave troll or something. VI Gremlin, and Gremlin is a part of a huge family, Apache. So it's all open sourced, and there is like a lot of documentation and tutorials, forums. And if you want to learn about Gremlin, there's an open book. It's called Practical Gremlin. And on top of that, there's very nice graphics. And they're all made by Katrina. Katrina used to be Yim, and now it's now Thompson. Can't imagine how that happened, but I'm not sure. She has a Tumblr with like hundreds of these cartoony things. So, yeah, if you have a programming language and you want a nice icon, then she's the go-to place, I think. Another shout-out is for G.V. It's spelled like in the over here in the URL is a bit different, but this is how you query a graph. So if you would just want to toy with graph databases, then use that. I didn't start using this until I finished my first proof of principle, which is a bit silly because a lot of stuff didn't work as I expected. So I had to change that. There's also a Discord, and the makers of this tool also answer general Gremlin questions. So let's look into a graph database, what a graph database is. They're nodes, and they're called vertices, and they are connected with edges. Of course, vertices have unique IDs to refer to them. They also have labels, and labels is probably what we would consider classes. So it is a bit of a mix-up between labels and classes as how we see labels and classes in LabVIEW. And those nodes have properties. And the edges also have IDs and labels, and they can also have properties. So that's a lot, but basically you have edges and vertices, and they have properties. So normally if you use Gremlin, you would make an application and use the Gremlin lib. This is I'm not an expert, but I imagine you'd use it like this. You have your application, and it uses a lib, and then you have a driver, and the driver can point to a cloud database or a JSON file or an XML file. And you can even store a graph database in an SQL database. It's just data, but it's what makes it a graph database is the way it's composed. So what I did, I couldn't use any of that, or I don't think so. So I made a Gremlin class to do it in LabVIEW, and then my driver points to VIs in VI server. And then I made the VI at the moment, so that's going to be a tool, hopefully, that uses the VI Gremlin class to query. So how would the graph look for a VI? Well, obviously there are vertices. They have labels, classes in our case. They have IDs already. LabVIEW gives them unique IDs. And they have properties. So that's pretty obvious. So how about edges? Well, wires have labels too, and they have IDs and they have properties. However, in a graph database, edges need to be one-on-one connected, and wires can be one-to-many or 0-to-0 if a wire is broken and doesn't have any connections. So that doesn't work. But what you can do is say wires are vertices, and then make edges between the wires. And that way we can module a VI like this. So from there on, there are like a lot of query steps that you can do. And for now, I'll focus on just filtering on properties during the demo. There are over 100 Gremlin functions, and you probably only use 20 on a regular basis. But there's a lot of funky stuff that you can do. So try to do a demo. If I can get my VI on that screen. Whoop. There it is. So it doesn't fit on this screen, it does fit on that screen, that's weird. So it also skipped a part of my presentation. So I'll just improvise. So over here there's the query. So with a V, when you do a V, it returns all the vertices in your graph. So these are all the UIDs, and they don't mean anything. I have to can click this, and then you get all the labels as well. Show them in a list, and well, there you have your first query. I'll move the target VI to the other screen as well. So there's a decoration, and there it is on my VI. Here's text somewhere. Oh, that's on the diagram. That's still on my other screen. Let me figure out why it's not. Put all this effort in scaling it, and now it doesn't scale. That's annoying. Whoop. There you go. That's what you get when you start doing that stuff in the day before presentation. So yeah, these are all the notes. And our first query results. So from there on, you can say, oh, this is what I do here is specify which class I want. So when I add that, it only adds the constants to my result. So now I only get constant results in my query. Usually Gremlin, you specify the ID, but in LabVIEW it's no use filtering on an UID because nobody knows the UIDs unless you're scripting. So I changed the functionality a little bit, and what you specify here is actually used to traverse the diagram. So when you do constant, you get all the constants. And this is just a silly VI, but it's just a variety of stuff. So you can do multiple, and then you get also the controls on my front panel and all the constants. So from there on, you can filter. So the query for filtering on a property or getting the property is values. And this is the label text. So now I get a nice list of all the labels. So now I cannot click it anymore because this is text and not a node. But while it traverses the database, my VI, it also builds a path. And I can watch I can look at the path, and there it goes from this node to the value. So I get a nice nice overview of the entire query steps that it took. So you can also filter on that, of course. So over here, I filtered on the non-empty labels. In fact, here I check if it's empty, and if it's not empty, then it returns true. And the next step would be to filter on that. So now I only get the non-empty ones. And I should be able to change this, for instance. Yep. So now I get the empty constants. Right, so these are labels, constants that don't have a label. So don't use constants that don't have a label. But yeah. So you can, of course, filter on all kinds of stuff. So containing the label 3, not containing age, whatever. You can obviously query a lot of stuff. You can also filter on the presence of a label, a property. So instead of returning all the nodes on my VI, it only returns nodes that have a broken property. So I get all the wires. And of course, I can return the value. And over here, there's a broken wire, and the rest is not broken. Again, I can filter those out. So here I check if a node has a value broken true, and that only returns this one. I can change this to false, of course. And that returns the other wires that are not broken. You can do stuff like counting, of course, count all the results, but now you lose your entire path because you go from all the items to one integer, so a path doesn't make any sense anymore. Yeah, there are a lot of properties that can be useful like this. So over here I return the names of a case structure. So this is the case structure, and these are the frame names. And they're returned if you ask for them. You can get like a cluster of properties. Then you don't get the values, but you get what's called, you get key value pairs. And you can do stuff with that. One note that I do add next to all the nodes on my diagram and front panel is the VI itself. Because when the VI itself is a node, I can actually get properties of the VI. Like now, this returns the code size of the VI. You can combine filtering. This gives the nodes the nodes that have a broken property that is false, and then also filters the width of 1, not 1, greater than 1. So the array has 2 pixel wires. I'm just going over the possibilities because it's quite hard to make examples for like a general search tool for VIs. This is quite similar, but over here I filter differently. This one returns all the text labels that are not attached, no, that are attached to anything. So over here, this wire is attached to the decoration. This helped me on the forum because there was like a huge VI that was corrupted, and a few attached labels, their wires went into space. And I wanted to make a screenshot, but I couldn't find it anymore because the VI was so huge. So I started searching the free labels, and I got an enormous list. Then I thought, okay, let me search for free labels that are attached. And then I got 10 labels, and one of them showed the corruption, so I could make a screenshot. Oh, this is a funky one. I didn't know that was possible, but wires actually have a value property. And now when I query again, actually the wire value changes. So now you have like an online monitor of the values of the wire, which is quite nice. These are all like solutions for maybe problems that you don't have, but it is. I'm just showing possibilities here. So let's get back to the presentation, hopefully. So now we probably get all the theory that I skipped. So this is a simplified module that I did not explain because somehow those slides skipped. But there are quite a lot of edges in a VI. You have not just nodes connecting to wires, connecting to other nodes. Wires connect to tunnels, constants, and once you start scripting, you run into this kind of stuff, and it's very difficult. There's also like clusters containing stuff. And all of these edges I gave, in my module, I gave a separate label. And that's very useful to make like unique labels, even though sometimes the names are a bit, well, they're made up by me. But if you give them unique labels, you can use the queries to be specific about what you want. So there's my theory. Would have been useful to have this in advance, but so you can query all the vertices, all the edges. I didn't show that, but you can get a list of all the edges connecting the nodes. That's in the next demo, so it's not completely wasted. You can be specific and get a specific edge or vertex. We saw that. So from there on, you can also traverse the graph from one node to another. So if you start with node 4 and you say out, you get all the outer edges, or in fact, you get the nodes that the outer edges point to. So if you do this query, this is my mouse. If you do this query, you get the adjacent nodes that are connected through an output edge. If you do an in, then you get the nodes connecting to an input edge. You can also return not the node, but the edge itself. And you can move around the graph with these commands. So I'll use those in the demo, so you don't have to memorize them or anything. You can be specific in these ins and outs. You can give the edge label, and then it will only return the edges that with the label knows. Or in our case, clusters or owns, diagrams own stuff, so you can get all the edges that own something or are owned by something. And I'll also introduce some other query types. So back to the demo. This is familiar. This is the same stuff that we did before. It returns a list of all the enum constants. This one, etc. And from there on, from these enums, I can get the outer nodes, or the nodes connecting to an output edge. So now you only end up with 2 enum constants, and the other nodes are not productive, so they are removed from the results. And you can see this node connects to this wire, and this constant connects to this wire. You can repeat that, and now you end up with only one vertex. And from here on, the tree might be a bit more convenient. This part of the screen is not over there. So we start at the enum, and then we take the out step, and those connect to the selector terminal and the left shift register and this tunnel. You can also add funky gremlin query stuff. And now we do get all the enums, and only if the node has an output, then it will be used, and if not, then you still get the result. This is another funky query. So what it does, it goes over all vertices and then gets all the edges that own. If they don't exist, it goes to the next one, see if it bundles, and if it doesn't own or bundle, it produces this text. And you get a nice list. This is just more funky stuff you can do with queries. Any questions so far? Yeah?
I have one. Is it possible to, when you have 2 graphs,
can you wait for the mic?
some kind of...
So just so it gets recorded. Oh, we don't have the microphone, it doesn't get recorded.
Is there
Can we get a mic down here?
I can repeat it. It's
Okay.
well, there's one on its way.
You mean 2 VIs?
Just wait for me.
Yeah.
So is it possible, so let's say you have 2 graphs, can be 2 VIs, maybe you're searching for just a subset of nodes within your VIs, so
Yeah.
let's say a global search function. Would it be possible to calculate the Euclidean distance between those 2 graphs, saying this is how equally they are, which would be great for a search algorithm for
I think it's. I don't think you would want to use gremlin queries for that, but you can definitely make dedicated gremlin functions to do stuff like that.
Okay.
Yeah. So instead of repeating the outs like what it was like this, so here I have 2 outs. Of course, if you want 40 outs, then it gets a bit annoying. You can use loops. And what I do here is I start with a top-level diagram. The results are emitted, and then in a loop I get everything it owns. And if it doesn't own anything, this will generate nothing. And if it has frames, then it returns those frames. So what this does is it makes the hierarchy of my entire diagram, right? So I start at top level. This is on the top level. I have a case structure. In the case structure, there is a diagram and another diagram, and this diagram has an add function. So if there are export functions for this tree, you could maybe use that for documentation, or you can, of course, filter everything, like all the previous filters you can apply to this to filter subsets or It's all pieces of the puzzle, and you can make the puzzle really complex if you want. So, oh, there's a spoiler. So how about querying a project? So far, we only talked about querying the graph or the VI as a graph, but the project is a hierarchy, and a hierarchy is a graph as well. I didn't put that much thought in querying a project as a VI yet, but it's a module, so you can change the module. So far, I was thinking like a VI calls a VI, class is a class, and eventually an interface will be, a class will be an interface, could be an interface as well. So these are the edges, and these are the, these are the vertices, and these are the edges that my module now supports. And back to the demo. You can do stuff like this. These are all the VIs that do not call anything. Yep. This is going to be annoying because they're all on my other window, I assume. Okay, this VI has no callers. It's in the text over here. VIs without callers. Or VIs that are not called. So this is a separate graph, right? Yeah, you have the project graph and the VI graph. Oh, another query. Return all the VIs with a specific number of callers. So these are the VIs that have 17 callers. You could also say greater than, of course, smaller than, between. You can even compare it with an array, so see if the number of callers is within an array of values. Find all the callers of this VI. This is in a tree, but in the list. So this VI is called by these VIs. So if you have a project graph and you want to step into a VI, there's nothing in Gremlin to do that. So you cannot go from one graph to another, but that's exactly what we want, because we want to do queries on VIs, and we have a project graph. So I made up this special function for that Gremlin doesn't have, and it's the switch function. So over here, I get all the VIs from my project, then switch into each individual VI graph. I get the VI node, which is basically the VI reference, and then I get this property from it. And there's an error, so what I say here is don't use it in a tree, because if the tree is open, it gets populated with 500 items. And it will slow down the demo hugely. The query itself takes a while, but not that long. So the list is quite useless, because that doesn't show the VI, but the list of VIs is... where's my scroll bar on that monitor? This is annoying. Right, so now I have a nice list of all the code sizes of all my VIs. Here's a query that returns all sub-VIs on my entire project where the third terminal is wired. This takes a bit longer than the other query because there are a lot of sub-VIs. Like the list of VIs is maybe 400 VIs, but if you go to the list of sub-VIs used in all those 400 VIs, it's quite a long list. So it won't take minutes, hopefully. Normally it doesn't. Maybe the demo makes it. Oh, demos usually make execution time longer. So here's a VI, and it's on my other screen again. So this is the VI, and over here the third terminal is wired. So the terminals of a VI are numbered from 0, 1, 2, 3. So this is the third terminal, and it is wired. This searches for all in my entire project for wires that have a label value that is not empty. You can, of course, query for text or specific text, even regular expressions. But this one takes minutes because there are like 50,000, maybe 100,000 wires in all my VIs. So I don't do that for the demo. This is a nice one, and in LabVIEW from 20 on, you have these for loop iterators, and you can hide them. So I like to hide them because less is more. I don't want like a blue thing doing nothing in my for loop. So I don't see the scroll bars over there and the list, so it's a bit improvising. So here's a VI on my other screen, of course. And there's a VI. It switches between screens, that's annoying. So this for loop, let's take another VI, this one's too difficult. Here's a for loop with an iterator that could be hidden, yes.
Couldn't you have, that your search query didn't take into account whether the iterator was connected in the previous one you showed? So your search query should check whether your indicator or your loop counter is wired.
I think it is. Like this is all the for loops. Has not a loop counter wire UID. So if the loop counter wire doesn't have a UID, it's not wired. So this step filters out if it's wired or not. Yeah. And this one shows if it's hidden, so it should be not wired and not hidden. Yeah. You can search for text in all kinds of ways, and here I combine stuff that is containing the word element and is containing to do, so you can merge that. The normal LabVIEW search can do that to some extent. You have to make a regular expression to put this on. And it will find the text, and I think it's... So at the moment it filters on VI, but you can also get the note, the text note that... there's the text. It should return the text. And in the path, there's the scroll bar again, and now of course it's scrolled the other way. My mouse pointer doesn't work that way. not sure what's going on here. It's struggling at the edge of the screen. Yeah, so over here you have the VI, and this is the text node, and it's on my other screen. Yeah, so there's the text containing element, hopefully. Yep. And it has a to-do. More of the same. Not too exciting. Oh, here I do or, so you can also, instead of doing an and, you can also do an or. It shouldn't take too long. Yep, there it is. What is it? Find colors and those colors and mind recursion. So yeah, this is where my module at the moment fails a little bit. So you can get this unfold VI, and it can be a few, I guess, if you do OO, and then all its colors and all those colors, right? So you get yeah, there's a long list, so I put this in this morning, so it works. Yeah, it's still waiting for a crash or something, but I'll put it in a list somehow. A list is okay. So here you have all the unfolds. Those could be the same, right? But it fans out, so you get all the outputs are unique, and then all the colors. Well, they all end up on my other screen, but it's not very interesting at all. So if you, I can probably say, oh. Right, so you get a nice hierarchy of all the unfolds and their colors and those colors. So I was preparing the demos, and I thought maybe it would be nice to show the repeat function. So I added this so it doesn't execute. So what will happen is that eventually my unfold will be called in the execute. And the execute is a recursive function. So all the executes are called in execute. So it's an infinite loop, and it never stops. So then I thought to be clever and thought I stop looping until the path becomes cyclic. So that means if you build the path traversing the graph and you find an element that's already in the graph, then it stops. But then it still takes forever because I have 200 execute methods. So you go from 200 executes to 199 executes to. So basically, this is. It would be nice to traverse all the VIs until you end up with the main. But I guess I have to work on the module a little bit to make that happen. I can repeat for 3 times, and then you get a hierarchy with a depth of 3. Yeah, not in a tree, but you can put it in a list. I skip this, and I'll round it up a little bit. This was the part of the demo that I could skip or make as long as I want, but we're already over. So a few elephants in the room. Labels versus classes is a bit annoying. So in Gremlin you have labels, in LabVIEW you have classes. But if you filter on labels, the labels have to be an exact match. So what you want to do is it a control, and then an enum control should match a control and not be the exact label. So there's a little bit of work there. Matching types is very difficult because there's a method to see if variants match that an eye has, and it has like 40 flags and I think 4 bits of results. So matching types isn't that easy, but you do want to filter on them. Writing values. So I only talked about querying, but how about setting the property? Like if the iterator of a for loop is shown and it can be hidden, why not hide it? But that opens all kind of worms of the undo stack and stuff like that. So I will work on that at some point, but math, like covering wires, Euclidean distance, yeah, would be nice. And you can just extend the gremlin functions with your own functions. So it just it can be done. The big elephant in the room, I guess, availability. So I wouldn't mind publishing this as open source, but on the other hand, I do want to keep working on it. And well, we all have this problem, like you want to work on it, but that takes time and money eventually. So if you have any ideas on how to make this public without stopping development because it's too much time to work on it, I'll be very interested. Future work, the graph, the picture control, if you make that editable, would be nice. Query function. I'm not sure what that meant anymore. So you're all waiting for lunch, right? So now I use VI Server to query VIs, but I also have API to query a JSON graph. And that basically means you can use VI Gremlin to interact with a database in a graph database from within LabVIEW. Yeah, put those queries on your diagram, and you don't need to script anymore. You can use Gremlin queries to get references and go from there. Would be nice to have export of those results and use those tables that are outputs as an input to other queries would be nice. Making a directory of queries and getting them automatically in a quick drop, right? Could be a nice feature. Storing like a library of queries in a Git repo, for instance, or things that I would like for this tool to be successful. So at the moment, I think the query language is good enough. Most of Gremlin is in there. That serves our needs. The VI module is probably good enough. The project module needs work. And, well, the tool is basically non-existent. Speed is an issue with scripting, always. Maybe NI can help there at some places. And, of course, we need like a VI Gremlin. Specifically for LabVIEW. Any questions? Oh.
Thank you, Wiebe. This is excellent. As usual, you show us stuff that nobody else could show.
Thanks.
I see myself using that tomorrow morning. That's wonderful. I would not worry too much about the UI, I guess. I don't know how your API looks like, but if we are already able to get the references of the result of the query, that's wonderful. I would not worry as well for writing the values, because again, from that list of references, then I can call the right scripting property.
Yeah.
I think that's already very, very good. Plugging that with VI Analyzer gives a lot of possibilities. I think you should show that to Darren Nattinger as soon as possible, because he's the VI Analyzer master, the scripting ninja, all that, so he will be very interested and probably will give you tons of useful tips.
That's why they need to be here, right?
If you don't have his direct contact, talk to me and I can help. More a comment than a question. Thank you. Wonderful.
Yeah, thanks. Yeah.
Can we drop any other questions in Discord, or is that okay? Or
Yeah.
pick up. Wiebe, you're happy to chat during lunch.
Yeah, lunch or yeah, during beer. Yeah.
I like it.
Thanks.